name is Balázs, and I work at the Center of Psychedelic Research at Imperial College. First of all, I'd just like to thank you for the organizers for inviting me to give this presentation. I realize this is a Friday afternoon, so basically I cut out some of the geekier slides of this presentation that I typically give at academic conferences. And what I want to focus on is to give you a bird's eye view of the sort of problems that I am working on. And the theme is really going to be placebo effects in psychedelics, both in microdosing and in macrodosing. In practice, what I will do is to walk you through 3 papers. One of them is actually published, the other one is under review, the other one we are about to submit, so it's in 3 different stages, but I think that will give you a good overview of how we are thinking about some of these issues. I actually have a background in physics. I studied physics, and I was already doing my first postdoc in New York when I realized that actually I would like to change my career and become a psychedelic scientist. And that was a very hard transition. So in a way, I had to invent myself to be a part of the psychedelic field. And that was the self-blinding microdose study, which probably some of you know of. That study is already published, and when we published it, I had some uneasy feeling about it. I mean, it's a solid paper and it's all good, but it had that issue that it was a placebo-controlled study, but we realized that the placebo control did not work as expected. And we were lacking some of the conceptual and statistical tools to deal with this situation in a more sophisticated manner. So that's going to be the second paper that I'm going to talk about. The issue, we are calling it the activated expectancy bias. It's when people realize their drug condition in a placebo-controlled trial. And then we're also going to propose a solution, which we are calling the correct guess rate curve, which is a statistical method how you can estimate the outcome of a trial as a function of the blinding's quality. And then last but not the least, I will also talk about how some of these placebo/expectancy effects are working with psychedelic macrodosing. So when the doses are large, and notice that is a fairly different problem, because if you are taking 25 milligrams of psilocybin, it's incredibly easy to distinguish that from placebo. So they're like blinding really just doesn't work as a concept. So that presents some new conceptual challenges. So before I move forward, let me just clarify that I will use blinding very often in this presentation. And by that, I do not mean we are poking you in the eye. I mean it as a medical term that we are not telling you what is going to be the treatment allocation. So please just bear in mind that whenever I say blinding, I mean it in this technical sense. And then just before we get going, I would just like to say that what I'm presenting mostly, I've been driving those research, but it has been very collaborative with other members of the center, in particular, David Nutt, Robin Carhart-Harris, but most importantly, my main collaborator with everything that I'm going to present was David Erizzo. So I'd like to acknowledge them and their contributions to this work as well. Okay, so let's get started. So first I want to talk about the self-blinding microdose trial. And as I told you, this is a paper that is already published. It was published last March in eLife, which is a pretty good scientific journal. If you scan that QR code, that's going to take you to the actual publication. And this was a weird study. And what made it weird is this self-blinding. So let me just explain what is that exactly. So self-blinding is this novel methodology that we worked out how self-experimenters at home can implement their own placebo control without clinical supervision. So traditionally, when you're conducting a placebo-controlled trial, you, the patient, go into a clinic where you meet the doctor, and the doctor gives you some drugs, and you don't know whether it's placebo or the active treatment. And then you go through the trial, and there are going to be some outcome measures, so on and so on. But the point is that the entire process is going through the clinic. That's where you get the drugs, and that's how the placebo control is incorporated into the study design. Now, with the self-blinding, we are breaking from that paradigm because we worked out how you at home can implement your own placebo control without any outside help. So basically, we can cut out you, the patient, visiting the clinic and meeting the doctor part, which is a few important consequences that I will detail as we go ahead. So I'm not going to have time to go into all of the details, how exactly this self-blinding worked, but I'll tell you the main points of it. And the most important trick is that we asked participants to hide their microdoses inside non-transparent gel capsules. And it was critical that the capsules are non-transparent because we did not want them to see what is inside. And this allowed us to use empty capsules as placebos. So this is going to be the part where I'm going to skip a lot of the steps, but basically participants prepared a bunch of capsules that had a microdose inside, which is just a small piece of a blotter paper, as you can see on the picture here, and a bunch of other capsules that were empty. Each of these capsules were then labeled with a QR code, and then these QR codes were, and then these capsules with the QR codes were mixed together. The participants randomly selected one, they scanned the QR code, and when they scanned that QR code, that connected with our IT infrastructure, sharing some information with us about that capsule. And it also told the participants what to do with that capsule. It was basically either discard that capsule or to put it into your dosing schedule, I don't know, the Tuesday of week 2, something like that. So they scanned these capsules sequentially, and what was the end of that process is that they ended up for capsules enough to take for 4 weeks without knowing whether those capsules contain microdoses or they are just empty placebo capsules. However, we, the research team, had that knowledge because when they scanned those QR codes, that information was recorded in our IT infrastructure. So, as I said, this is not a traditional clinical study. It's quite far from it. But because of that, it had some unique pros and cons. And let me actually start with the negative. So most importantly, the biggest drawback of this design in this psychedelic space is that we didn't give the participants the drugs. So because of that, everybody sourced his or her own drugs from the black market, which leads to some uncertainty. What was exactly the chemical composition of that microdose and what was the exact microdose dose used. However, I think that is a relatively small price to pay for the positives, because what's incredibly cool about this self-blinding process is that it's very, very cheap. As I said, we are cutting out the patients visiting the clinic and meeting the doctors, and that's what makes clinical trials expensive. Basically, this study costed about 1% of what is even a small size clinical trial. And what's also really, really cool about this methodology is that because everything is run through the internet, you have a global reach. Typically, when you're running a clinical study, you can only recruit from your own city where the clinic is because they need to come into the clinic. So you're restricted how big of a patient population you have access to. But with this methodology, because everything is run through the internet, basically you can recruit globally. And that's the reason why this was the largest placebo-controlled study to date. We have managed to put through 191 microdosers through this protocol. And that's 191 who actually finished the study. A lot more people signed up, but 191 finished it, which is a very, very large sample size for a placebo-controlled study on psychedelics. And again, this costed us somewhere in the neighborhood of about 15,000 euros, which is just like absolutely nothing when it comes to costs associated with clinical research. For a second, I would also like to return to the negative. So as I said, that there is uncertainty with respect to the exact drug and the dosage used. But in a sense, I think that's also a positive. This study not meant to be representative of a clinical microdosing regime where we exactly know that 10 micrograms of LSD is taken every second day or whatever. But the point is that this has a much better external validity. It is much more closer to how real-life microdosing is done. Because when microdosers out in the real world getting their microdoses, they're also getting it from the black market predominantly. So all of the uncertainty that is present in this research, it's not unique really to this research. This is part of the microdosing world. So in a way, I believe that even though this is not like a controlled clinical study, but in a sense, our results are much more representative of real-life microdosing than a very rigid and controlled clinical study. And last but not the least, I would just like to take a step back with this methodology and just reflect on a few things about it, because I think this has applications well beyond psychedelics. So traditionally, when we are thinking about evidence in medicine, evidence-based medicine, we are thinking that broadly there are the observational studies where you don't have any control group, and we are considering it low quality evidence. And then we also have the RCTs, the randomized controlled trials, that are very expensive and complicated to do, but they are yielding this very high quality evidence. And traditionally, we don't think that there is anything really in between those two levels. Either you are running this low-level observational study or this high-level clinical study. But I think this self-blinding, this is something that actually fits somewhere in the middle. It's clearly not an observational study because you have the placebo control group, which is arguably one of the defining features or the most important features of traditional RCTs. On the other hand, it is clearly not a traditional clinical study because there's not even a clinic. You don't see the people. They are preparing their own placebo control. So what I enjoyed most about this study is that it really forced us to think about, okay, what is important about a clinical study? Why is placebo control important? It makes you think about how you value elements of a clinical study differently because this is not a standard methodology. As far as I know, this was the first self-blinding study, not just in the psychedelic literature, but in the broader medical literature as well. And we think that this has applications well beyond psychedelics. We are in the process of setting up a similar study with CBD, and we are also in talks with some supplement companies, and hopefully with them, we will also set up some other self-blinding studies. So think about sleep supplements, cognitive enhancers, and the like. Okay, that's enough about self-blinding. Sorry, I'm super excited about this methodology, so it's very hard for me to keep back on this. But hopefully you see that it has value. So we use this methodology. As I told you, 191 people through this study, which makes it easily the largest placebo-controlled study on psychedelics. But what is it that we actually found? And first, I will talk to you about what we call the accumulative outcomes, and that is the change from baseline to after a 4 weeks long microdosing regime. Now, note that in these figures, there is also the 4 weeks follow-up time point, but I'm not going to go too much detail into that because where really the most important change that you see here is the change from the baseline to post-regime, as we are calling it on this figure. So this is one of the outcome scales that we measured, mindfulness. And in a second, I'm going to show you all of the other outcomes as well. But I would like to walk you through this figure because this is representative of pretty much what we have seen in all of the outcomes. So first, please just have a look at the red line, which is corresponding to the microdose group. So that's the group who were taking microdoses 2 times per week throughout the 4 weeks long dosing period. And as you can see, there is a nice increase from pre-regime to post-regime. And actually that change is statistically significant. So microdosers' mindfulness scores improve statistically significantly over the course of this 4 weeks long microdosing regime. And I think importantly, this validates a lot of the anecdotes about microdosers or microdosing. Microdosers did better on these mindfulness scores. And notice that when you are microdosing at home, this is the effect that you are going to experience. It is going to be this change from the pre-regime to the post-regime. So far so good, but obviously, where things are going to get a lot more interesting is when you're also considering the blue line, which corresponds to the placebo group. So these are people who were taking placebo capsules for the entire 4 weeks long dosing period. And as you can see, their scores also went up. And actually, the change is no longer statistically significant relative to the microdosing group. So both the placebo group and the microdose group did improve. And yes, the microdosers improved a little bit more, as you can see on this figure, but the between group difference is not statistically significant, meaning that statistically speaking, the placebo group improved just as much as the microdose group has improved. So in a way, microdosing did have an effect, but it did not have an effect that is larger than the placebo effect. So this is the mindfulness outcome. What about the other ones that we have measured? So I need to move my mouse. Okay, yeah, there you go. So you can, so what was the primary outcome of the study is what you see here, the well-being. The RPWB, that stands for RIF Psychological Wellbeing Scale, which is a fairly comprehensive questionnaire on well-being. And qualitatively, the story is exactly the same as what I told you with respect to mindfulness. If you look at the microdose group, yes, there is a statistically significant increase from baseline to post-regime, but the placebo group improves as well, and there is no statistically significant between group difference. I already showed you the mindfulness on the previous slide. Life satisfaction, qualitatively exactly the same story. Paranoia, qualitatively exactly the same story. Now notice that with paranoia, you want less, so that's why the line is going down. That is actually an improvement. The last one, the cognition, the CPS, that's actually not exactly like the others. And notice that in this case, the change from baseline to post-regime, that was not statistically significant, either in the microdose or the placebo control group. And so that's weird, like that behaves very differently from all of the other outcomes. Is there an explanation for that? And I think there is. And for that, what you need to know is that all of the other outcomes that we have measured were self-reported questionnaires. So it is basically an online questionnaire where you are rating yourself how well you are doing with respect to various psychological constructs. The only exception to the self-reported outcome was the cognition, the CPS, which stands for Cognitive Performance Score. For that, participants were needed to log into a cognitive testing platform, and they need to go through 6 cognitive tasks. It's like, think about, like, you know, those memory card games that probably everybody played as a child. Also, there was a test on reaction time. There was also a mental rotation task. So they did these 6 cognitive tests that were individually validated before our study. And then we sort of like merged those 6 scores together to what we are calling CPS, the Cognitive Performance Score. But the main point here is that everything else is a very subjective outcome, which is self-reported, and there seems to be a very strong placebo response in it. But in cognition, which is arguably the only objective outcome that we had in the study, this placebo response didn't show up. And it makes sense because it is well known in the placebo literature that objective measures are less susceptible to placebo effects compared to the subjective outcomes. One important point that I would like to emphasize here is that these measures, these outcome measures, in a sense, were not selected by us. Before we launched the study, we had a very small scale pilot study with 10 microdosers, 10 veteran microdosers. And we showed them a bunch of questionnaires that, hey, given your experiences with microdosing, what do you think is what questionnaires are the best to capture the positive effects of microdosing? And they selected these outcomes. And I think that's important because we often get that criticism that, okay, but you didn't select the right question or the effects of microdosing. And that may be the case, but actually there was a lot of effort on our behalf to include questionnaires that were selected by veteran microdosers who have experience of microdosing. One thing which is not on the slide is that we also have measured the big 5 personality traits, and there was no change in any of the traits. As probably some of you are aware of, openness is a trait that tends to increase after macrodose experiences, so large doses, but we did not observe that with microdosing. Okay, so how do we interpret it? Like, what's the big picture here? And I think the 2 important observations here, and one of them is that microdosers experienced improvement in a wide variety of psychological outcomes. And I think that validates a lot of the anecdotes about microdosing. However, it seems that taking placebos is sufficient to reproduce all of those benefits at the same time. So it is important, and I would like to emphasize it, is that in my opinion, it's not that microdosing doesn't have an effect. I think that's not a true statement. Microdosing does have an effect, a positive effect, and that effect just happens to be not greater than the placebo effect, which suggests in a sense that it's very likely that the placebo mechanism is also responsible for the changes that we see in the microdose group. But the point is that microdosing has an effect, but that effect just happens to be equal in magnitude to the placebo effect. But that's not the same as not having an effect. Very often, when I give this presentation, people are saying, "Oh, and you argue that microdosing does not have an effect." That's not true. We never say that. Microdosing clearly has an effect. It's just that the effect's magnitude is not larger than the placebo effect, which is not the same statement. So these were what we called the accumulative outcomes. And this was, again, the change from baseline to after a 4 weeks long microdosing regime. But we also measured some other outcomes that we called the acute outcomes. That is, you take one of these capsules, and how are you doing 2 to 6 hours later? And you can see some of that result here. Now, what's important to emphasize is that if you look at the placebo versus microdose p-values, you can see that actually there is a bunch of measures here that are statistically significant. So if you analyze the data in a naive way, then you would conclude that, hey, okay, the accumulative outcomes, there wasn't a microdose placebo separation, but seemingly in these acute outcomes, there is. Even though if you look at Cohen's d, which is a measure of the standardized mean difference, the effect size tends to be fairly small. I don't want to get too geeky here with statistics, but Cohen's d is a measure of the effect size. And by convention, if it's less than 0.3, that means that the effect is fairly small. So the p-value in a sense tells you whether there is a true effect or not. And the Cohen's d is about the magnitude of that effect. And it's important to emphasize that even in this naive analysis, there is, even if you accept this, that there is an effect, the effect's magnitude is fairly small. Now, what's cool about these acute measures is that every time these were completed, at the very end of those questionnaires, participants had to respond to a single item, and that is that, hey, if you have to take a guess whether your capsule was a placebo or microdose, which one you think it was. So this is what we are going to call the guess data, the treatment guess data. What was the capsule that you have taken earlier that day? And it turns out that this data is actually very critical to understand microdosing, because what this guess data allows you to do is to check for the quality of the blinding. Now, if participants are genuinely blind, then they should not be able to guess their treatment allocation better than random. So it means that the correct guess rate should be about 50%. That's how much you get it right just by chance. However, when we looked in the microdose data set, what we have seen is that it was 72%, which is much, much higher than the 50% for a properly blinded trial. So actually, what does that suggest? That yes, we did have a formal placebo-controlled procedure in this study, but the placebo control did not work as intended because side effects or other factors still gave it away in many cases, whether a placebo or a microdose was taken. So the correct guess rate was 72% in this study, and you need 50% for order it to be considered an effectively blinded study. Let me add quickly that the 72% has nothing to do with this funky self-blinding methodology, because if you look at all of the other microdose studies that have been published since, all of the traditional clinical studies, the correct guess rate is about 70% in all of them. So this study certainly got that right. And actually, may I add quietly as well that this correct guess rate of 70%, this is fairly representative also of more traditional psychopharmacological interventions such as SSRIs. With SSRIs, it tends to be a little less. The correct guess rate is around 60 to 65%, but certainly higher than the 50%, which would indicate a properly blinded study. Now, what's important is that traditionally, if you're running a clinical study and you measure this correct guess rate and you notice that, hey, it's very, very high, probably this placebo control is not working, then most clinical teams won't do anything. The best case scenario is that they are mentioning it in their upcoming publication, but there is almost zero effort in the literature to incorporate this information into the interpretation of the results. And if you ask me, I think that is just bad science. We don't have placebo control just so your statistician can make a living by doing between group comparisons. We have a placebo control group in these studies in order to eliminate expectancy biases. And if you don't check your blinding quality, and if the blinding is broken, then the same expectancy biases can find their way back into your trial via a mechanism that I'm going to call activated expectancy bias. So this is where I'm going to transition basically to what is the next paper, which is currently under review. And I'm going to keep using data from this microdose study. But I think it's very important to appreciate that in this next part of the talk, what I'm going to discuss is much broader than microdosing or even psychedelics, because what I will talk about is that at the heart of evidence-based medicine, I think there is a big contradiction. And that is that we are considering the blinded placebo-controlled studies as the gold standard of evidence, but nobody is checking when the blinding is working or not. By other groups who have done systematic reviews on this topic, they have estimated that only about 2 to 7% of trials are checking blinding quality. And when blinding quality is checked, it's found to be weak in about 50% of the cases. So on one hand, we are glorifying blinding and placebo control as the hallmark of high quality medical evidence, but nobody is bothering to check whether it is actually working functionally as intended, or if the placebo control group is just there for the showing. And when we realized this, we looked at the literature and we were really just surprised that nobody's talking about this issue. And I still don't understand why. Like, either let go of blinding and you don't care about it, and that's fine. But if you think that the placebo control and blinding is the hallmark of great evidence, then you should check whether it's working or not. So with that, let's move towards the activated expectancy bias. And the correct guess rate curve, that's going to be this analytical technique that I have mentioned in the introduction that will allow us to adjust the outcome of your trial for the quality of the blinding. On this next slide, what I am showing you is a very high-level schematic representation of what is going on in a trial. So this is not really specific to any particular trial. This is a high-level abstract representation of what you think is going on. So notice there are two pathways on this diagram between the treatment and the outcome. And first, let's talk about the blue one, because that's the easier one. That's the direct treatment effect. And that's how psychopharmacology is supposed to work. You take a drug, it has a treatment effect on your outcome, you get better, yay, story done. But we think that actually there is this other pathway, the red pathway as well. And really the key element here is that there is a relationship between treatment and perceived treatment. And notice if there is an arrow there, that is when you get that correct guess rate of higher than 50%, if those two are correlated. And what we are proposing is that side effects and the other factors are often allowing participants to reduce their treatment allocation. And the whole point of this activated expectancy bias is that once you, the patient, have realized that you are either in the placebo group or in the active treatment group, then your expectations about that treatment are going to influence the outcome of the study exactly in the same way as they're influencing the outcome of non-blinded studies. So like in the case of, let's say, SSRIs, like they often have a side effect of dry skin. And if you are conducting your trial ethically, you have to tell your patients what are the likely side effects. So you go into this placebo-controlled trial, but the doctor tells you that, oh, and by the way, the active treatment in this trial has a side effect of dry skin. And then a few weeks later, you notice is that, hey, you know, my skin is really, really dry. Most people can put it together that I'm in the active control, I'm in the active group. But then after that, you're not really blinded anymore. You broke the blind, you unblinded. There are various ways to talk about it. But the whole point of it is that the blinding was not functional. You broke the blinding. And then expectations are going to play a role exactly the same way as in an unblinded study. And that's what's represented by this top pathway at the top. So What I'm going to do next is just to show you the correct gas rate curve, which is basically a method of eliminating this red pathway, or actually that's not exactly true. What we are going to do is that we are going to make sure that the red pathway is contributing equally to the active and the placebo treatment arm of the study, so we can estimate the true active placebo difference. And to do that, I'm going to apply the correct gas rate curve on the microdose data. So this is a pretty busy figure, so let me walk you through it. So first of all, let me just highlight it that this is the PANAS. This is the positive and negative effect scale. So this is one of the acute outcomes that we collected in the microdose trial. And this is one of those outcomes that actually had a statistically significant microdose placebo difference when we analyzed the data without considering the quality of the blinding in the trial. So what we have here at the bottom is if I do this, oh yeah, you can see this on the screen, great. So the correct gas rate curve is at the bottom of the x-axis. And this figure has two y-axes. And what you can see here with the blue, that is the treatment p-value. So the p-value associated with the microdose placebo difference. And on the other side, you have the treatment estimate. So how big is that effect? Now, these dashed lines are also pretty important to understand what's going on here. And first, let me just say that this purple horizontal dashed line, this is just the threshold for statistical significance. So as you can see, this is drawn at p equals 0.005. So basically, if the blue line is below this pink line, that means that actually you have a statistically significant result. If you are above, it's not a statistically significant result. Now, the other two important lines are these dashed vertical lines. And this green one is drawn at 72%. And remember, when we looked at the correct gas rate in this microdose trial data, it was at 72%. So that's why it's drawn there. It corresponds to the correct gas rate that we have empirically observed in this trial. The other dashed line, this black one, that is drawn at the correct gas rate of 50%. And remember, that is actually a critical value, because if your study is properly blinded, then the correct gas rate should be 50%. So what's going on here? The important point to look at is that where this green dashed line intersects the blue line, because you can see it is actually below the significance threshold. So if you are looking at the data naively, then you would conclude that there is a placebo microdose difference, as I have just shown you a few slides before in the table. However, the other critical point is that this black dashed line intersects the blue line at well above the significance threshold. So what this suggests is that actually, if the correct gas rate would be 50% in the trial, i.e., if your trial would be properly blinded, then there would be no statistically significant placebo microdose difference. So what we are suggesting is that very likely this positive effect is a false positive, which is driven by this activated expectancy bias. It is driven by patients actually unblinding in the study, and therefore their expectations still influencing the trial outcomes. So this is the PANAS. This is one of the positive outcomes. What about the other ones? And practically, if you are using this adjustment method, then for everything, all of the other positive outcomes that we had in the study, after this correct gas rate adjustment, the effect is gone. So it was also gone for the mood VES, the VES that stands for visual analog scale. So when you are moving a slider between 0 and 100, again, as you can see, it was originally statistically significant, but after you are making you're estimating the blinded version of the study, then the effect is gone. Now, at the bottom row, I have two other cases that don't behave like the other ones, where simply the effect is gone. With the energy VES, the effect is actually still there even after this correct gas rate curve adjustment. But notice that the effect size is much lower. And you can see that where the red line is intersecting the green dashed line and the black dashed line. So what does that mean is that if the study would be properly blinded, there would still be a statistically significant placebo microdose difference, but the magnitude of the effect has been overestimated by about 40% if you are not considering the quality of the blinding in your study. Last but not the least, it's our old friend, the cognitive performance score that I have also discussed in the context of the cumulative outcomes. And notice as this looks like, it looks unlike all of the other outcomes. It's basically a flat line both for the p-value and for the treatment estimate. And what does that mean is that with irrespective to what is the correct guess rate, i.e. irrespective of the quality of the blinding, you don't have an effect. And again, that makes sense because this was the only objective outcome in the study. So you would expect here expectations to have a much diminished role. And that's what you are seeing is that even after the adjustment for the quality of the blinding, the results are essentially the same. So hope you agree with me that these figures look, well, at least cool and pretty, but how did we get that? And I am going to skip some details here, but I will give you a bird's eye view of the methodology of how we have constructed these. So I'm going to here describe like very abstractly, just high level, how the data processing works. And again, this is not specific to microdosing. So let's say that we have some outcome measure and we had 100 people in our study and that the correct guess rate was 70%. And that's what you see on the top with the purple color. And that is the histogram of that outcome score that you are interested in. And then what this algorithm does is that it takes this distribution and then based on the guess data that we have collected from the participants, it constructs two subdistributions, the correct guess and the incorrect guess subdistributions. So in the correct guess, we have people who have taken a placebo and thought it was a placebo and people who have taken a microdose and think it was a microdose. And in the incorrect guess, when the perceived treatment and the treatment does not match up. So we have these two subdistributions, and then all what we are doing is that we are fitting a statistical model, a kernel density estimate on top of those distributions. And those are the red and the blue lines, that's what you can see here. And once we have these distributions, all that we do in order to estimate what will be the outcome at the correct guess rate of 50%, is that we are drawing an equal number of random samples from these distributions. And that is going to give you a pseudo-experimental data set with n equal 100, which was your original sample size, but very importantly, the correct guess rate of 0.5, which corresponds to perfect blinding. Now, this last step, when we are drawing the random samples from this kernel density estimates, that is actually repeated 100 times just to reduce the influence of each of the random samples. So what I showed you in the previous slide, that was the average p-value and the average estimated effect size across these 100 estimations. And so this is how we got the correct guess rate of 0.5. But notice that we can schematically follow the same procedure to estimate what would be the outcome of a study at, let's say, the correct guess rate of 60%. In that case, you are drawing 60% of your sample from the correct guess subdistribution and 40% for the incorrect guess, and so on and so on. So that's how we managed to construct the correct guess rate curve of what would be the outcome of the trial at every possible value of the correct guess rate. So this is, again, a high-level overview of this methodology. In this paper, which is currently under review, we really focus on the concept. We think there are multiple ways of doing this. We want to also include some Bayesian analysis in this, and we want to make our estimation method more sophisticated. And there's going to be a follow-up paper where we flesh out alternative implementation choices when we are constructing this statistical pipeline. And in this paper, what we're really talking about is just this concept is that actually you can use statistics to adjust your trial outcomes for the quality of blinding. Now, what I would like to talk next is that for people who have keen on stats and are into graphical models have probably noticed that, okay, but I have cheated here a little bit. And the way I have cheated is that I have assumed that the reason why there is a high correct guess rate is because there is this arrow between treatment and the perceived treatment. So we are assuming that the side effects are giving away the treatment. However, there is an alternative scenario, which is called the benign unblinding on this figure, where the source of the unblinding, the reason why participants are realizing that in the active treatment group is because of the very much increased outcomes in the study. So practically what that would mean is that you are going through this blinded study, you take your capsules, and then you experience such improvements that you notice that it must be that you are in the active treatment, because these vast improvements cannot be explained by anything else other than that you are in the active treatment. And in the psychological literature, these two cases are called malicious and benign unblinding. Jeremy Hauk is somebody who wrote a lot about this. So we borrowed his terminology. Now, everything that I said only makes sense if we are talking about malicious unblinding. If it's benign unblinding, then actually none of it matters what I said. And actually, then if you apply our correct guess rate technique, you might have some false negatives in your study due to what is called a collider bias. So before you use this tool, it's super important to distinguish whether these two cases, and this needs to be done on a trial-by-trial basis. So because of that, I can't generally claim that this is the case, but in the case of microdosing, I have two, I think, pretty strong arguments that we are talking about the malicious unblinding and not the benign unblinding. And one of the reasons is that we simply asked participants that, hey, what was the primary cue why you guessed microdosing when you guessed the microdose? And 55% reported body/perceptual sensations as the primary cue. So this includes like stomach discomfort, muscle tension, roughly what is known as the body load in the psychedelic literature. And only about 23% of the people have reported that some improvements is the reason why they have thought that they were given a microdose. The other argument why unblinding was malicious is a more quantitative one, and I find it actually stronger. And that is that we have found a study that did not have any intervention, but it measured the aforementioned PANAS scale, the positive and negative affection scale that I have showed the correct guess rate curve for, on consecutive days without any intervention. And what they were interested in is that what is the within subject variability of that scale? What is the natural variability, the ebb and flow of life? And what they have found is that the average within subject variability on that PANAS scale is about 10 points. However, the mean placebo microdose difference was only 2 points. So it means that the placebo microdose difference is about 5 times smaller than that average variability of that measure, which very strongly suggests that it could not be benign unblinding, because that 2-point difference can get very easily lost in that 10 points average difference in the day-to-day variability of the PANAS outcome. So this work is currently under review, as I have mentioned, and importantly, in the supplementary materials of this paper, there is a guess of treatment questionnaire, which is a very, very brief questionnaire. But what it does is that it asks participants for the treatment guess in a way we think that is best. And it also contains some items to assess the source of unblinding. So whether we are talking about malicious unblinding and benign unblinding. And if you're running a clinical study, I strongly I ask you to consider including it in your study, and for 2 reasons. One of them is that it's also a security blanket for you to check whether your study is actually placebo-controlled or not. And the other one, which is more selfish on my behalf, is that we can collaborate and plot these cool correct guess rate curves for your particular study as well. So please do have a look if you are interested. As I've mentioned, these concepts, the activated expectancy bias, the quality of blinding, and the correct guess rate curve, this is not really specific to microdosing or psychedelics. It's just that we happen to have microdosing data. And what we want to actually do with this is that apply it to a bunch of interventions. And put next to each other the blinding quality adjusted outcomes from microdosing, from SSRIs, from ketamine, from TMS methods, from whatever we can find. But basically the point is that to create an equal, a level playing field for all of these interventions, irrespective of the quality of the blinding. We do have some data for other interventions, like for example, for ketamine. But if you are aware, or if you have friends who are doing clinical work and they happen to have a trial where treatment gas data was collected, please connect us, because we are very interested in collecting as much data as we can, and then have this future study where we're making an apple-to-apple comparison between the interventions with respect to the quality of the blinding. So last but not the least, I would like to transition to talk about large doses. So far, I have only talked about microdosing. And in the introduction, I have said that actually all of these issues with macrodosing work a little bit differently, because you cannot really properly blind with the large doses, because the drug effects are just way too obvious to be easily confused by most participants. So how to deal with that situation? And what I'm going to tell you now is based on reanalyzing some of the data from Robin's paper. This is a very influential study, the trial of psilocybin versus escitalopram, which came out in the New England Journal of Medicine last year. So this paper was actually a little bit, I almost said the word controversial, but that's not the right word. It wasn't controversial, but it's a hard to interpret study. So I would just like first to very briefly talk about why it was difficult to interpret. So typically when you're running a clinical study, you have multiple outcomes that is roughly measuring the same thing. And what people traditionally do, which is not good scientific practice, is that they have, let's say, 10 depression measures, and with that, there is a 10 times increased chance that one of those measures is going to have a statistically significant placebo drug difference. And then in your manuscript, you're only reporting that outcome and forgot that there was also 9 other outcomes that were negative. So because of that, it is standard practice in science, in clinical studies, that you have to define what is your primary outcome. What do you think it's going to, where do you expect the effect to be? And in this particular trial, that depression measure was what is known as the QIDS, the Quick Inventory of Depressive Symptomology. So QIDS was one of the 4 depression measures in this study. And in the QIDS outcome, after 6 weeks of treatment, there was no difference between escitalopram and psilocybin. Escitalopram is one of the most commonly prescribed SSRIs, at least in the UK, but I'm 100% sure that it is also used in Sweden. It's your standard antidepressant medication. So on the predefined primary outcome, there was no psilocybin escitalopram difference. But on all of the other depression-related outcomes, there was a difference, with psilocybin being better than escitalopram. So this is a weird situation, because if you are somebody who does not like psychedelics and want to be critical of psychedelics, then you can say that, oh, the primary outcome was negative, everything else is data fudging, you just showed that psilocybin is not better. If you're somebody who is more pro-psychedelic, then you can also make the other argument that, hey, okay, this missed on the quiz, it just happened to be by chance, because look at all of the other measures, psilocybin was better. So there is this tension in this interpretation of the paper that's sort of like how you value these two things, and whether you are somebody who is more looking at psychedelics through a positive or a negative lens, you can make your case, and that's why it's a hard to interpret study. Also, when the study came out, we received a lot of letters to the editor, which were highlighting the aforementioned problem, specifically that this paper was written up that, oh, this was a double-blind study. Patients did not know which treatment they belonged to. But of course, that's not true. Again, 25 milligrams of psilocybin, which, by the way, is roughly equivalent to like 2.5 to 3 grams of dried mushrooms, it's a very noticeable effect. It's not like a super mega, like, Terence McKenna kind of trip, but it is definitely something which is going to induce strong visual and other hallucinogenic effects. So a lot of the papers, letters to the editors have pointed out is that, okay, but this is not really a fair comparison because it's extremely likely that patients have unblinded. And given that it was conducted at Imperial College, which is known for its psychedelic research, it's very, very likely that the patients who have been involved in this study have a pro-psychedelic bias. They have higher expectations for the psilocybin than for the escitalopram. Many of these critiques were arguing. And I must say that those critiques were 100% right. So we have measured expectations with respect to the psilocybin therapy and escitalopram therapy at baseline. So this is even before the randomization happened. And as you can see here, that the expectations for psilocybin therapy are more than twice as high as compared to the escitalopram therapy, which argues for is that, okay, so patients had a much more positive outlook on psilocybin therapy. And even though the trial was formally blinded, patients were not told whether they are in the escitalopram or the psilocybin group, but very likely after the first drug session, everybody knew who was in which group. And in that case, the blinding did not protect against expectancy. It's important to say here that, so for the vast majority of trials, when you are measuring expectation with respect to the treatment arms, it's very likely you're going to see something like this, in particular in studies that involve a placebo control arm. I have not seen a single patient who is signing up for a clinical study wanting to be in the placebo control group. Everybody wants to get better, hence everybody has some expectancy bias towards the active treatment arm. And that is why blinding is critical, because if you can have higher expectations for one treatment over the other, but if you do not know which treatment you are getting, it just doesn't matter. But that's exactly what is broken in the case of psychedelic macrodosing, that you know what you are getting because of those very obvious drug effects. So this expectancy imbalance, it's in itself not an issue. This is becoming an issue where it is combined with the lack of functional blinding. Unfortunately, in this paper, we did not ask participants to take a treatment guess. So we do not have a formal way of calculating what was the correct guess rate and to quantify that. But I think we can, fairly confidently say that it's very likely it was somewhere around 95%. Probably not everybody would have got it right, but very close to it. So we have this expectancy imbalance in the data. And then how that is going to influence actually the outcomes in the trial. So first I'm going to show you how, the axis labels are missing here. I apologize. I'll tell you what is what, but anyway, my mistake. So what I show you here, what is the HAM-D at the top, that stands for Hamilton Depression Measure, which is one of the most commonly used measures of depression in clinical studies. And what we have here, so what you see on the x-axis, this is the expectation with respect to the treatment that was administered for the participants. Actually, you know what? I'm going to move on to the next slide because here you can see which arm is which, and there's also the axis labels. So anyway, it doesn't matter. Apologies. So here at the bottom, we have the treatment expectancy. So what was your expectation? And then on the y-axis, we have the change score. So after the 6 weeks of treatment, how much change there was on one of these outcomes. Important to know that we're talking about depression measures, so lower is better. So when the line is going down, that actually means that patients are doing better and better. So the way that we are plotting this data here is that we are plotting it with respect to the treatment arm. So people who have been in the escitalopram treatment arm, they are in the blue, and the psilocybin arm is the red one. And if you look at the blue one, you can see that with higher expectations, so the further you are here, the outcomes are better. The line is going down, and that makes sense. The higher expectations you have, the better you are doing. This has been verified in a number of clinical interventions. But notice that psilocybin doesn't behave like it. Actually, psilocybin is almost a little bit going up, but don't read too much into that because I give you here the corresponding p-value for basically for the slope of these lines, and it's not significant, meaning that strictly speaking, that line should be flat. What you see is the best fit line, but because the interaction term is not significant, you can ignore the slope of that and treat it as a flat line. So this is for quids, which again was the primary outcome of this study. But you can see that this pattern holds for all of the other outcomes. So here for the Hamilton, qualitatively is the same story. In the escitalopram arm, patients get better with higher expectations, but not in the psilocybin arm. BDI, the back depression inventory, exactly the same story. MADRS, exactly the same story. STAIT, so this is an anxiety scale, so it's not exactly depression, but qualitatively, again, same outcome. WebWebs, it is a well-being scale, and here actually there was nothing was significant, so that behaves a little bit differently compared to the others. But the point here is that this is actually a super surprising finding because generally speaking, treatment expectations are associated, higher treatment expectations are associated with better outcomes for a number of interventions across a range of medical conditions. And here what we have found that actually that's not the case for psilocybin. Now notice that if these results stand the test of time, then this is great news for psychedelics, because that means that all of this possible criticism that these studies are unblinded and therefore it's like expectancy plays a role and this is just a bunch of hippies, that's gone because those pre-treatment expectations just would not matter. But there is an alternative possibility, and this is a false negative. I don't know which case it is. It would be so much better for psychedelics if these results are true, but I want to be super cautious with these results because they are so good for psychedelics. And also because admittedly, this is just one trial. So let's wait until other trials are replicating these results. But again, if this is true, then this is, I think, a major, major good news for psychedelic therapy because it answers a lot of criticism around the lack of blinding. Now, that's what I want to talk about, which is another sort of like fancier statistical analysis, is that, okay, I told you that in the escitalopram arm, higher expectations are associated with better outcomes. That's not true in the psilocybin arm. And the other thing that I told you before is that patients have a much higher expectancy for psilocybin. So that raises the question, a counterfactual question that, okay, what would be the outcome of the trial if there would be same expectancy for psilocybin and escitalopram therapy? And that is what I'm showing you here on this next slide. Let me walk you through this one as well, because it is a fairly complex one as well. So on the x-axis here, we have the mean or the average expectancy. So what we have simulated is that what would be the outcome of the trial if everybody would have, I mean, if both treatments arm would have an average expectancy at, let's say, 20 here, 40 here, 60, so on and so on. Importantly, the outcome of this analysis is a function of what is that mean expectancy. So that's why it is plotted as a graph. So similarly as before, here we have the treatment p-value. So whether there's a between treatment difference, is psilocybin better than escitalopram? And on the other side of the plot, we have the treatment estimate, how much better it is, what is the magnitude of that change. And as you can see that really for the majority of the slide, there is actually a statistically significant difference, like up until here about 60 or something, when this p-value starts to shoot up. So when you are in this region, if this is the average expectancy, then there is no statistically significant difference. And by and large, here in this region, psilocybin is better than escitalopram. And here at this very end, if the average expectancy is very, very high, then escitalopram would be better. So what we are showing here is that depending on what would be that shared expectancy value between psilocybin and escitalopram therapy, there would be more often than not a significant difference between these therapies. And in more cases, it would still favor psilocybin. So this is for the Hamilton depression measure. But when we have made the same plot for all of the other depression-related outcomes, qualitatively, we had the same finding. So this is the paper which is we are about to submit. So there should be a preprint out soon. Yeah, so this is something that this is the first time that I am showing these in public. So this is roughly what I have prepared. So I would just like to wrap it up just by giving again a bird's eye view of what I talked about. So we have this self-blinding methodology, which we think it's a super cool concept of how to introduce placebo control into citizen science. And importantly, this technology is available for other researchers. So we have the IT infrastructure set up more or less. If you are a researcher or you know of researchers who would be interested in us, please feel free to reach out. We think this has applications well beyond psychedelics. When it comes to microdosing, I think there are two important observations that I told you about. One of them is that we know that microdosing does something, because otherwise, how are you explaining that participants can guess their treatment allocation correctly at a much higher rate than chance? So microdosing does have an effect. But the other important observation is that there will be no significant placebo microdose differences on any of the outcomes if when we are making that correct guess rate adjustment, when we are estimating the outcome, if the trial would be perfectly blinded. So what does that combines to is that maybe we can think of microdosing as an active placebo, which is to say that microdosing may be an intervention that does have some easily recognizable effects, hence explaining why participants are breaking the blind, but that does not have robust medical benefits, explaining why after the correct guess rate adjustment, we are not seeing any of the effects in mood-related outcomes. Now, notice that I've put up here was just a reminder for myself that in a healthy sample, so in our study, people were by and large healthy. So it was not for the purposes of treating a clinical condition. And I think generally speaking, that's one of the big questions that's remaining on in the science of microdosing. Other studies with healthy people on microdosing have by and large had results that are in sync with our results, but nobody has done a microdosing study in a clinical population, so where people have a diagnosis of, let's say, depression. So the activated expectancy bias and the correct guess rate, I think the most important there, that's not specific to microdosing and psychedelics. I think it's much broader than that. And the most important sentence that I'm going to say tonight is that please appreciate that there is a difference between trials that happen to have a placebo control group and trials that are actually controlling for the placebo effect. And the difference between the two is the quality of the blinding. And the only way to track the quality of your blinding is to check the correct guess rate or some similar methods. Again, we have this questionnaire included in the in this preprint. So please have a look at that, and then we can collaborate and make these cool looking correct guess rate curves together. So in the expectancy, in the macrodosing side of things, so again, a very surprising finding that we did not find an association between expectancy and positive outcomes in the psilocybin arm, which is great news for psychedelics. But also there I didn't get into the effect size measures of that last paragraph because I was a little bit running out of time. But the point is that if there would be equal expectancy between psilocybin and escitalopram, then yes, microdosing would be, psilocybin treatment would be often better than escitalopram, but the magnitude of the difference is still small. And we are working on more on quantifying that. So I think, the sort of like the takeaway message with respect to these macrodosing therapies, I think, is that, like, what happens if blinding just does not work? There's a lot of enthusiasm for using active placebos and whatnot. And recently there was a big study from NYU that used active placebo against psilocybin, but the correct guess rate was still 94%, I believe. So like nobody was really fooled with that. So I think, this is the really interesting question, because with EBM, evidence-based medicine, we have this fetish with blinding, but here we have a very promising new set of interventions, the psychedelic interventions, when blinding as a concept does not work. So there is a lot of friction there, that how we are going to deal with that. And we have some statistical and other methods of maybe how we can overcome that. Last but not the least, I would just like to say that my funding is nearly running out at Imperial. So if you know of researchers here in Sweden or elsewhere who would be interested in thinking about this, then please feel free to pass my contact along, and would appreciate contacts. So that's roughly what I wanted to say. I'm also a little bit running out of time. So thank you for your attention, and let me know if you have questions.
Thank you so much, Balázs. So if anyone has any questions, you can raise your hand. You can begin here.
So there's some debate towards, or there's some misconceptions about what a microdose is. Which dose range did you tell the participants to aim for?
We told them to microdose the exact same dose as they would dose outside of the study as well. I think this is a little bit like, almost intentionally mystify the dosing in microdosing. I think, what really matters is that, microdosing is exciting if there is a psychedelic dose, which is not large enough so that it interferes with your day-to-day activity, but which is large enough that it has effects greater than the placebo effect. So I don't like, when we are rather than trying to define what is the microdosing dose range, I think a much better way of thinking about it is whether a dose exists, which is small enough so that it does not interfere, but which is large enough that it has some actual benefits. That's how I think about it. Just so one thing that just reminded me, so recently I met with Vince Polito, a colleague from Australia who's going to run a microdose study with treatment-resistant depression. For example, they're going to use 5 milligrams of psilocybin, which is certainly not a microdose. So, I'm curious already how they're going to write it up. It's more like a mesodose, not quite a microdose, but not a macrodose either. It's in that in between.
What do you think about a stimulant, maybe amphetamine, as a placebo in macrodoses of psychedelics?
I don't think it would work. And the reason for that yes, it's a drug that has effect, but psychedelics have very characteristic effects. And if you're running your study ethically, you still have to tell your participants what are the likely effects. And also at this point, everybody, read the Michael Pollan book. They roughly know what psychedelics are going to feel like. So yes, amphetamine does have an effect, but, it's still going to be pretty easy to see when, everything is morphing into butterflies. That's pretty easy to distinguish compared to the effects of amphetamine. So that's why, I think it's cool, we should try to put active placebos in these studies. But as the NYU study shows, that actually use an active placebo, that's unlikely to solve the issue, because the effect profile is still going to be very different from your psychedelic intervention compared to whatever is your active intervention. In order to have an active placebo, we would need something that feels like a psychedelic, but what is not a psychedelic. Good luck with that.
Hi, I really appreciate your focus on research methodology. This is like what we have to focus to make the research field take us seriously. Working on Carl's question there, ketamine as an active placebo. I mean, ketamine has an antidepressant effect and also, I know, effect for addiction in certain studies. What does that hinder us from using ketamine as an active placebo? Because a lot of these criteria you counted up, it would fulfill.
But the issue there, then it's not an active placebo, then it's a comparator study. Then you're just comparing one active drug against another. And there's actually a big debate in the literature about whether placebo-controlled studies are superior to comparative trials, which is what you're describing. I think, one way forward is exactly what you described, comparative studies, but they have their own set of issues. So I think it's not that there's going to be a golden design, that solves all of these issues. What we need to do is to do different study designs, all of them having their own compromises, but hopefully they're going to point towards the same big picture, and it's going to be convergent evidence coming from these varied study designs. But yeah, comparative studies, I'm up for it.
So there are some questions in Zoom, so I will just go over and read some. So Yes, thanks for that interesting talk. I'm curious about your opinion on open placebo trials, so studies where the patients know that they are receiving a placebo and an effect of the respective treatment can still be observed. So from Paul.
Good question. So I must admit that I know this is a hot topic now, but it's not something that I have a strong opinion of because I haven't really read too much on the literature. So yeah, there are some papers that, so what they're doing is that they're telling people that, hey, buddy, here is a placebo and it still has a positive effect. And this has been reported in a number of small studies, but some people are criticizing it for methodological weakness. I don't have a strong opinion again because I'm not too familiar with that literature, unfortunately. So I'm just gonna take a neutral stance.
Thank you. So from Rawad, I think this might have been covered, but what the dose was used in the studies, did you measure that? Or
sorry, what?
The dose in the studies? I know you just told them to use the same, but did you try to quantify it?
I mean, we asked them that how much they think that they are taking, but this is like, one of the limitations of the model that we have used is that like, it's like, we would need to collect sample from the drug in order to quantify it. We actually explored it a little bit, like it was in the original protocol, but then the issue is that if somebody is doing the study, let's say in Sweden, and then they would need to send the drug sample to the UK where we can analyze it, it's crossing international borders, and then like, customs get one of these packages, and yes, it's for a scientific study, but it's easy to see how that could go wrong, right? So in the end, we just said that, okay, this is just something that we're gonna ask participants about it, how much they think that they are taking. But that's the best that we could do. But notice that this is not necessarily a property of the self-blinding model. If psychedelics would be legal, then, and you could go into a shop, we would have a pretty good idea of how much is exactly that dose. So this is a property of black market. This is not a property of the self-blinding method. Sorry, I have a soft spot for the methodology, so probably you have noticed that.
So from Ludwig, incredibly interesting research, both for psychedelic science and scientific methodology in the medical fields. I have two questions. So for the self-blinded study, what substances were allowed or included? Classic serotonergic psychedelics or anything else?
So it was just psychedelics, but within psychedelics, we tried to accommodate everything that was possible. So the vast majority of people, about 3/4 of them used LSD or some LSD analog, and the remaining 4 used psilocybin mushrooms. Actually, there's a funny story here. So when we released the psilocybin, the issue with the psilocybin mushrooms is that the weight of the microdose capsule is going to be large enough that you feel the weight difference compared to an empty capsule. So we had to find something that, you need to fill up the placebo capsule with, so the weight is equal and doesn't give it away. And I think the original protocol said sugar, and some people started to do the protocol, and then they told us is that, hey, actually it's pretty easy to unblind because, they're burping a little bit and it introduces this mushroomy flavor in the back of your throat. So we need to make the protocol burp proof. So then we asked participants to fill the placebo capsules with a non-psychoactive mushroom. I think it was chaga mushroom that we used in the end, which doesn't have any psychoactive properties, but what you can buy in natural health shop. It's meant to help the immune system. So that was painful, but we managed to make it work for mushrooms as well. And then I think there were like 1 or 2 people who used like mescaline, very, very small, 99% either LSD or psilocybin mushrooms.
Thank you. And what are your ideas regarding how to overcome the difficulties with blinding in macro doses?
I don't think you can. I think, we should let that go. I don't see that, how we can do it, particularly in an ethical way where we are revealing patients what's likely to be, and let me backtrack a little bit because I think this is interesting and important. Let me go back to this slide. I'm going to start far off, but then I'm going to answer this question. The way we are approving drugs, it's incredibly weird because if you have a new drug and you want it to be approved, then what the FDA and the regulator is going to look for is a placebo microdose difference. So what we are looking at is this distance, the distance between the red and the blue line. That's the placebo microdose difference. But that has nothing to do with the improvements that patients are going to experience when that drug is approved and you go to the doctor. What they're going to experience is this, the change over time. So one of the contradictions of the evidence-based medicine movement is that this is what we are approving drugs on, but it has nothing to do with what the patients are experiencing. This is what the patients are experiencing, the change over time. So I think, the blinding issue, we're not going to be really able to overcome it, but I'm just not convinced that, sort of like that is the most rational way to approve drugs to begin with. And like, there are issues here, there are reasons, why regulators typically don't look at this. But I think, the way forward is to make an argument that, hey, yes, blinding studies are important and are part of the equation, but you also need to consider that change over time. And then again, I don't believe there's going to be like a golden study design that is going to solve all of these issues. But what I think is important is that we do a diverse range of studies with a diverse range of designs. And hopefully, fingers crossed, they're going to converge all towards the same interpretation. And then I think that should be strong enough for regulators to accept. I would also like to add that notice that blinding is practically impossible with large doses, but it's not that only it's impossible for psychedelics. There is a very large number of interventions where blinding does not work. So think about mindfulness meditation interventions. Placebo control is impossible there, or any exercise-based interventions. So it's not like, that psychedelics are weird where blinding doesn't work. Actually, what is weird if the blinding works, like, so like with the SSRIs where blinding is possible, that's a very, very small set of interventions. There's a much greater set of interventions when blinding doesn't work. So I think, we need to accommodate that more into the evidence-based medicine framework and to combine these in a meaning. I don't know what is exactly the recipe, but I kind of feel like, this is what we need to play around with.
Thank you so much. Is there any other question? Yeah. Yes, so there was someone before who wanted to know if, did you check for microdosing if they were taking SSRIs? Are there any possible interactions of SSRIs and microdosing?
We did some sub-analysis, and don't quote me on that because I'm just like, searching in my memory, but we did some, and like we definitely asked for medications that they are taking together with microdosing. And I think I don't remember anything because very likely the results were the same for the non-medicated group as the medicated group. It's probably somewhere in the supplementary. So if that person is interested, look at the supplementary. If it's not there, they can email me and I'll look it up.
Hello, thank you for a great talk. Regarding the plots on the macro doses with expectancy and effect, have you in the lab, like they're really, really interesting. Have you in the lab like discussed what in psilocybin would possibly make it so different towards other substances in general? With regards to this?
I mean, honestly, so like, one thing that we have explored with is that like people generally have always high expectation for psilocybin. So maybe it's like a ceiling effect that, we don't see variability because there is limited variability in the expectancy score. And we did some quantification for that in the upcoming paper. And it's not exactly there. To be honest, I have no idea. I mean, as I said, this would be great results for psilocybin, but right now, if I would have to take a bet, I would say that this could easily be a false positive down the line. Like, if what we would find here is that psilocybin is that expectations are associated with positive outcomes, then I would be much more confident saying is that, oh yeah, this is how it is, yada, because then there is no contradiction with the rest of the literature. But here there is. So I just want to be super cautious, and just highlight that, yes, great finding. I hope it's true, but I don't know if it's true really.
Hello, I have two questions regarding the time frames when it comes to microdosing. And one is that if you look at those figures that you're showing, the gradient of the two lines is obviously different. So would you say if the time frame of the trial was increased, then the difference would be statistically more significant, perhaps?
So it's about microdosing now,
Yes.
Right? Maybe, I don't know. The issue here is that like, for this trial, so this is the macrodose, and this is 6 weeks, but they only have 2 drug sessions. With microdosing, it's difficult because they are taking a drug almost every day. So it's incredibly difficult to run long trials. Like that 4 weeks was already incredibly difficult. I hope somebody will do a 6-week trial, somebody will do an 8 weeks long trial. And yes, maybe there are effects, but it's technically super challenging to do. So like, I don't plan to do it. But if somebody is up for it, I would like to see the results as well. I don't like, how to put it, like I don't feel very positive about microdosing anymore. I mean, it's not a great secret, but when we came up with this self-blinding, the vision is that we're gonna be the cool people who show that it's not just a placebo effect. And like, obviously, that didn't really work out. But the point is that it was already incredibly difficult to do these 4 weeks. And if you look at the anecdotes, many people are reporting positive effects within just a few weeks, certainly within 4 weeks. So right now we know that the effects are not there within 4 weeks. So therefore, those anecdotes are probably accounted for by the placebo effect, right? Then, there's some other anecdotes that are saying that, okay, there are effects after 6 weeks. But then, given what we know right now, I'm just a little bit more suspicious of those anecdotes. I'm not saying that they are not true, and I'm not saying that microdosing does not have an effect on longer timescales. I'm just saying is that based on what we know today, I have grown to be suspicious of, more suspicious than before. Yeah, makes sense or good? Yeah.
Hey, I'm just wondering about the cognitive tasks that you used in the microdosing study. Yeah, just what they were and whether you had sort of different effects in the different tasks, because I think you lumped them together into a...
Yes, so I will not be able to give you the exact list. It's on the paper. Yeah, it was sort of like this. Most of them was like sort of like spatial rotation and memory related tests. I think there was one scale where there was a very small effect. I think it was the rotation task where microdosing may had a very small positive effect. But it's definitely in the supplementary, the sort of like the task by task results as well. So if you look it there, you will find it there.
So any other questions? No, well, I guess that's it for tonight. So thank you so much, Balázs, for making it all the way here. And it was a really great talk. I think this is really fascinating. And this is like a really crazy slide that I have to try to understand. But thank you very much. And thank you everyone for making it out here. Yeah.
Yeah, thank you.